Okay, first up, we are going to be doing cohort 2 meter presentations. First up is going to be Sarah Gombash Lampy. Lampy? Did you say it last time? Yeah, Lamp or Lampy? Lampy. Okay, Lampy. From the Ohio State University.
Ani, you're right. It is a little weird with the microphone. Okay. Hey, everybody. Happy afternoon. So I want to introduce you. You always see me, but I have a team behind me. They just don't show. They're real people. They're there. So the team of content creators that I'm working with are Martin Hasemeyer, Andrew Fisher, and Cole Vonderhaar. We're all in the Department of Neuroscience at the Ohio State University. I'll refer to it as OSU now on. And then we also have an instructional designer on our team, Carrie Rubidoux. So she's from the College of Medicine, which we sit into. So this is my team in their entirety, even though they occasionally people see Carrie, but otherwise it's my face all the time. Sorry. Now, we are working on a collection of 3 units. So the order that you see them on the screen is the order that we've been working on them in. And so most developed to least developed. And the first that we tried to tackle and are working with Center closely on figuring out is effective data visualization for research communication. Now, I'm going to be talking to you about that unit in the next slide, so we're going to pause with that one. The second one that we're working with is about data sharing and trying to get the learners, trying to give them some structure for transparent and thorough data sharing. And I'll show you a little bit about that one at the very end. And then the last one, this has a controversial title from last year. It has not been changed from phase 1, but identifying rigor red flags in research reports. And this one's really about helping especially a novice learner begin to know what questions to ask when they start looking for rigor. Okay. And this is actually one of the most challenging units that we have been thinking about, but it ties in really well to nearly everyone else's unit. So this is the last one that we're working on. I'm mainly going to be talking to you about data visualization today. And to be able to walk you through the activity that I want to describe, I have to give you some context. So what you're seeing on the slide at the top are our ultimate broad goals for what this unit will teach. And ultimately what we want is we want learners to understand, in short, the roles of data visualization and research and how incredibly important it is and can often be the primary or first thing that anyone experiences. It's the first impression of your research. I mean, who doesn't really open up a paper and look at that figure, right? So they need to understand its importance. I'm betting a lot of learners do, but they haven't ever reflected on that and its importance in the context of their own work. We also want to equip learners to identify key considerations when designing or analyzing data visualizations, plots, and graphs. We are really about, this unit cannot be about teaching them how to use a tool for data visualization. There's a lot of tools. Any of those tools could go out of style. Any of those tools could go away. We can't do that. What we are trying to do is get them to ask the questions about data visualization and how it's related to rigor, so that for whatever tool they use and the decisions that they make, they're at least aware and thinking of rigor the entire time. The third thing we're trying to do is we're trying to build their confidence, right? So you can, again, I think we've touched on this a million times in the past 2 days. You can tell them what to do. You can guide them. But if they're not confident, they don't have an attitudinal shift about it, doesn't matter. Doesn't matter, right? We need to give them confidence when they are creating their own data visualizations and thinking about their work that they can actually, do this. It's feasible, it's plausible, they can do the best thing. So what you're seeing on the map down below is our little, it's Old Raven, if you can see him, he's in our little car. It's our roadmap. I know he's cute, right? I didn't change him on purpose. No shade to the new Raven, but I was like, he's cute. So what you're seeing here is our lesson map. Now, our lessons all have titles, but I don't feel as the titles are super helpful. So what you're seeing in each block is the question that we want the learner to ask. So what we're doing first is we're having them ask, how is data visualization used in research? We're going to focus on it in this unit more on reporting research, but we are telling them about its role in discovery, right? Looking at trends, identifying these different patterns in data. Then we're asking them to reflect on how is data visualization related to rigor. And one of our reflection points will talk about that. Then we ask them, what do the plot choices tell about my data structure? And we realize that data structure might be a little bit of a weird term there. But the goal of the third lesson is to reveal to them that just the plot choice you make tells, and it could be assumed, but tells a lot of information about your experimental design, the groups that you have, and what you're looking at and how they were analyzed. Now, again, that might be a lot of assumption on a reader's part, but it's a thing that people need to know. Then we're going to talk them through what plot choices there are, maybe some, I hate to say best, but better practices or better plots for displaying data and why, the strengths and weaknesses. Then in 5, we're going to talk to them about data variability. What do you do with it? What are some good ways to handle it and plot it? Then we're going to address multidimensional data. Multidimensional data. What is it? How do you utilize it? What are your options for looking at it? Then in 7, we're going to talk about what makes a data plot user-friendly. I think in our actual title, it's fashionable and accessible choices, but really it's about if someone from outside your field comes and looks at this, let's make sure that they have even a chance at understanding it and they're not walking away with misinformation about your data story. And the last one, which is highlighted in yellow, is related to the activity. Instead of giving more content, we decided to do a knowledge check lesson. So instead of giving them more information, we want them to take variables and information that they've learned from other lessons and apply it. So that's the activity I'm going to show you. But to get there, I had to show you all this, okay? So this is a sketch of what this activity looks like. And I was actually talking to Dave about this activity yesterday because it's got a lot of moving pieces. I think it's very feasible, but it's got a lot of moving pieces. Ultimately, the goal of this activity is for them to take from earlier activities and content knowledge from earlier lessons and see if they can put it together. And they're going to put it together in a multi-panel style figure. Now, I don't want to spend my time teaching them how to use a tool to make a graph. So what I want to do is give them preset options to choose from to learn a lesson. So the learner will come into this unit and they will have experimental context and data visualization. Or I'm sorry, data information up there. Okay, so they'll have that. We're going to give them an experimental scenario. We're going to give them some data. They will have the appropriate background. It's not going to be every nitty gritty detail. That's boring and a waste of time. It's going to be what they need to know. And then from there, they're going to be asked to make choices that are relevant to our other lessons. So in one of our, well, 2 actually of our lessons, we're going to talk to them about plot type and what the plot type reveals about your story. And so we will develop preset choices about plot types. And in this, it's showing you entire plot types they can pick from. This is what I'm working with Dave to kind of figure out how many choices I can have. But they'll be able to pick based on the scenario, the plot type that best fits that information and plug it in to be one of their panels. Plug it in. I can't see my pointer up here, so I don't want to ruin it. But plug it in to be one of their panels. Each choice that they make, so maybe we can get it down to them to making a choice about a plot type and an axis, or a plot type and where a plot point is. Maybe we can get it to there. I got to work with the production team. Has an automatic feedback bubble that's going to pop up. That's really important. So they'll get some feedback on, I want to say good, better, and maybe even better, not even best choices. I don't want to put in too many bad choices because those are pretty obvious. That's not helping anyone learn. And then they'll do that for the other 4 lessons too. So the second panel, let's say panel or plot B in our panel, I should say, is going to be about variability. And we're going to have them question in this scenario with this data, you have a point that doesn't match in everything else. How do we display that? Or how do we display variability between groups? And then they have to make best plot choices to go after that. The third, C, is going to talk about multidimensionality. So in this experimental context, they're going to have to deal with that, but we'll give them the context for that. And then accessibility, all right, thinking about, is everything labeled properly? Is everything red and green? That's not a great choice. Are things clear? How is this read? How is this looked at? So this is the ultimate activity. The narrative of this unit, I don't think is necessarily super spicy or sexy, but we came at it from an authentic perspective, which is we have a trainee that's going to make a poster or write a paper, and we need to be able to get them to really think about how to construct this transparently and thoroughly so that their figures represent that. And I think when we thought about, our team thought about reflections, I'll start with the bottom one. So this was actually something that Martin Hasemeyer said in the group, that I think when you think about rigor and data visualization, you start to think about rigor and data visualization. We say DV now because that's hard. When you pick out your plot and start plotting, but that's not when it starts. When you even conceptualize the idea that you're going to show data in a visualization is where your rigor choices start. So we're starting to teach from that point. Now, granted, experimental design, it's much farther back, but if you just think about the practice of making your data visual, the choice to make your data visual is a choice in rigor, right? We've also thought about, I'm really into affective learning domains, you probably heard me, but thinking about what are the motivations for doing this properly and how we can bring that out in our activities. And then when we were developing this unit, it taught us that we knew, but it really reinforced there's no single right or wrong. There's no binary, you should do this in this figure and you shouldn't do this in this figure. So how can we adapt our materials so they're really driving home the questions? What questions should you be asking when you start this process to make sure that you're doing it the best that you can? And then our next looking forward is, I just shared here the data sharing unit. For as much as data sharing, don't throw eggs at me, is so not my thing. It's not spicy to me. I'm in love with this unit more than the data visualization one. And it's because of the way we're constructing it. And so I know it's like, don't. Okay. But I love this. So we're leading the learner into the benefits of data sharing for the sharer. Then we're leading them into challenges in data sharing related to rigor. Of course, that's what we do here. Then we're taking them through how shared data is actually used. We're talking to, and we're floating in on metadata for that. And we want to pull them in a choose your own adventure style thing on how to create report, thorough and transparent metadata under the guise of no matter what repository you're sharing in, no matter what formatting you have to use, if you cannot tell the context of the data is useless. If the details aren't there that people need to use it, it's useless. So I'm actually way more excited about this one. But I didn't have enough to like show you guys that unit, the activities drawn out. I am excited about that one too. So that's what we're working on. We'll be working on the rigor red flags, and many of you will get bothered by me for that because there's a lot that's going to feed into that unit.
Yeah, next up is Boston.
Hello, everyone. So I'm Ori from BU, and my team is me and Mark Kramer, who's in back there. We're from the Department of Mathematics and Statistics at BU, and so all of our units are related to issues of statistical rigor and data analysis. And so we have 4 units all related to that. The first one is on powering your experiment. So how do you decide on a sample size to determine how much data will be enough to identify a meaningful hypothesis? Our second is about evaluating the statistical methods you use and the assumptions underlying those statistical methods, how to think about not only using which statistical methods to use, but what the underlying assumptions for those methods are and whether they're appropriate for your analyses. The third is about putting p-values in context, understanding not only what p-values mean, but when it's appropriate to make an argument about evidence using p-values, and when other options for expressing the strength and evidence in your argument are maybe more powerful arguments to make. And the last one is about making exploratory analysis more reproducible, in particular by being aware of issues related to multiplicity, multiple comparisons, and multiple ways to mitigate those problems. And so there's actually a common kind of narrative theme and structure for all of these units, which is that we start each unit with one scientific question, and the individual lessons in the unit guide them through that using data to answer that scientific question. Each of the units has one data set that the user engages with, and in the different lessons, they engage with it in different ways. And so I want to give everybody kind of a flavor of that in the first unit here, the sample size unit. We've already developed kind of prototypes for each of these units. And for the prototype for the sample size unit, it's kind of developed enough that we've actually applied it in a number of our classes. And it starts by really throwing students into the deep end. So the very first activity is we give them a scientific hypothesis. So let's say there's this substance that people have discovered that we're going to call substance X, and you have a hypothesis that this might be a genetic biomarker for longevity. People who express more of this substance, your hypothesis is that they might tend to live longer, and maybe you have an explicit idea of what the effect size might be in your hypothesis. And the goal is to come up with a sample size to use for a follow-up research study. And so we give students just two pieces of information. One, that this substance X, that might be a biomarker, has a normal distribution in the human population. And we're going to give them the data, a z-scored version of this across many subjects, however many subjects they ask for. And the belief, the scientific hypothesis, is that individuals at the highest level of expression for this substance tend to live about 5 years longer than people at the lowest level of expression. And then what we do is the very first activity is we say, give us the sample size. Tell us what the answer is. And so we give them some tools. So first of all, we tell them, this is the point of this. You don't need to know the answer right away, but we give them some tools that they might use. So we link them to the NIH website that gives them a sample size calculator. And we also link them to an online repository that has 24 other sample size calculators for all sorts of situations. And in many of the cases where we've applied this, students have already taken an intro stats class and learned something about sample size. So we encourage them to go back to their textbooks and kind of figure it out. But the first activity, they have to give us a value of n. And so I just wanted to show you, I deployed this in a class with about 37 students. These are PhD students in neuroscience who have all taken at least one statistics class that has dealt with sample size. And this is the distribution of results that they've come up with. You can see anywhere from 10 samples to 1,600 samples, really, quite a uniform distribution among this. But not only did we ask them for, what sample size would you use here, we also asked them, how confident are you? And so we get about half of people who, even though they've taken a stats class, talk about sample size, say absolutely no certainty. We get about half people who say, I'm not totally certain. I think I'm correct or I'm close, but I'd want to consult with more, but I feel at least okay with this. And then out of this whole class of 37, one person said, I'm certain about this. By the way, that certain person was also way off. But it just goes to show that even people who have learned this topic already have a sense for the importance of the topic, still have trouble when presented with that question of how to actually solve it. And so after that first activity, what we ask them to do is to plug in to ask for that amount of data. So we have code, we have a huge data set underlying this, and they can ask for any n that they want for the amount of data, and then to just conduct the analysis that they would conduct in order to determine whether the effect is real here. And so, we tell them, we give them this challenge, we ask them to plug in this n, and that's how much data we give them. And so if you guys get bored as I'm talking, if you want to play along, you might be able to just go here to where the kind of prototype of this is. I'm not sure, can I actually click on this? Yeah, so here's an example of what it looks like. I don't know how to go, oh, here we go. And so this sample size one, you can see it's kind of an interactive notebook. It, starts with this question that says, even if you have no idea how to answer this, here are, ways you might approach it. But then you get down to here and you're asked, plug in a value n. and run the code and try to implement it. And then you can actually see the results. And so if you want to play along, you can try to do that. Okay, let's see. Can I get back to the actual slide itself?
Why are you going back? Can you define what you mean by failure? Doomed to failure.
Oh, yeah. So if you go down here, so if you, let's try running this and see if it works. So if you plug in 100, which is about the average of what people do, and you run the code, let's see if this will work. You end up with a result that shows the expected result with very insignificant results. So I can see, did this work? So you end up with, this as your 100 data points, and you can go on and do an analysis, a regression, and you end up with a p-value of 0.37. Even though the effect, I don't know if you kind of look at the slope itself, so that's later on, but if you look at the estimate itself, you actually see the result in a small amount of data, and it's not significant. And so we have a unit later on that says well-powered experiments are doomed to success. So just basically going in the progression from having an underpowered experiment and seeing the result, but not being able to achieve significance. Well, in this case, I've generated data where the result is true. And so for this data set, not being able to detect it means that you don't have enough data to detect what is present in the full largest data set there.
Also, by chance, get a large effect. Right? That's the problem from underpowered studies. You get a large effect.
Yeah, and so you can actually see that. So actually, the next thing we do is we keep sampling 100 over and over again, and sometimes you get a very large result as well. Okay, so now I need to figure out how to get back.
Probably have to just like, I don't know what that's doing. I don't know what we did.
Mark said that this would probably break it, so you were right.
Yeah, do you know how to fix it? On your side, right?
Clinically meaningful results versus statistically significant results in here?
Well, so I think our p-value unit is really focused on that you can get things that are statistically significant. You can get p-values that are extremely low there, and they just relate to results that are not meaningful at all when you have extremely large data sets.
Nope.
So that is something.
I closed the wrong tab. Very good.
Yeah. Yeah.
Why can't I? Whatever. This is.
I think maybe.
There we go.
Okay.
You just don't have a presenter view anyway.
No worries. Okay. And so this also highlights another theme of all of our units, which is that we let the users explore the data and play around with the data, but we set traps for them. We lead them down wrong ends. And in this case, the expression of the problem is very simple for the sample size, but people tend to vastly underestimate the actual sample size that you'll need. And when they do, they tend, in this case, to fail to detect a relationship that's actually present in the data. And then what we give them is multiple options to go back and figure out what went wrong and how they're going to correct it. So for example, later on in this unit, they realize by resampling the data multiple times that whenever they sample 100 data points, for example, they get very variable results in it. And then we ask them, what approach would you like to pursue? We give them options. We tell them why they might be useful. And then we give them multiple options, none of which are the single right option. So in fact, there are paths through this that can lead them to a proper sample size by just resampling from their original pilot data. They can get it from building models, either building models from their pilot data or building models based on the few expressions that we've given them, or they can, stick to their guns and just decide whatever they decide as their current sample size, that's what they'll use for the full experiment. And some of these paths really aren't helpful, and so we lead them really to a dead end, but multiple of these other paths are helpful and will lead you to meaningful computations of sample size. And so what we found through prototyping this, building it and prototyping it, is that many learners are already aware of issues related to this, but really don't feel confident in doing it themselves. And so our philosophy is really to give them a chance to learn by doing. Most of these units have this kind of early trap that leads them to a wrong conclusion and then steps back and has them really reflect on, first of all, figuring out that conclusion was wrong and why it was wrong and what could be done alternately. In all of these, we have the option either to build their own code to solve kind of prompted questions one step at a time, or to be provided with code and then to be taken through that code one step at a time to understand how it's working, or to not look at code at all and just have the result of the method that was discussed spit out. So people can do it who have no programming background, but people who maybe have programming background can learn that they can build it themselves. And we also feel that this kind of choose your own adventure style, first of all, reinforces that there isn't a single recipe, that we're not guiding them and telling them this is the one way to do it, that allows them to go through multiple approaches and get to correct answers, and maybe allows for this kind of notion of replayability. What if I didn't choose this way? What if I chose this other way? What would I have gotten? And how are they related? So I think that's everything. You know, we've built these kind of prototypes for each of the things. If you want to play around with them, you're welcome to. And so I think right now we're focused on completing at least the short version of each of these units. Thanks.
I believe next up we have University of Washington at Jevin. Thank you.
So first of all, thanks, Yuri. That was amazing. That pie graph of certainty is pretty amazing. So hi, everyone. I'm Jevin. I wasn't here last year. You've mostly seen Carl. There is another Carl. I'm not Carl, but I'm the other version on the team. There's others on the team, Bing and Katie as well. My background is a little strange, like a lot of us. I'm actually in what's called an information school. I'm a professor in an information school where I work next to, I'm trained as a biologist, but I work next to economists and computer scientists and philosophers. And I spend most of my research time in the darker corners of the internet, which makes things very depressing, which coming to things like this, where we're working on interventions to misinformation, at least in this case, misinformation around science, makes for life being a little bit better. But that being my focus, thinking a lot about the ways in which misinformation travels, of course, on social media, online and offline. I care a lot about how misinformation travels even in our institution of science. I think what motivates a lot of the work here around Rigor is to improve that, because some of it's intentional, but most of it, I think, at least in our research that we find, is not intentional. And so recently, there actually is going to be a consensus report from the National Academy of Sciences coming out in a few months that I was one of the lead authors, where we look at misinformation in and about science. And as you can imagine, that can be politically challenging when we're looking inwardly at our institution. And one of the things I wanted to reference is that there are efforts in the NIH. I think we were able to get some things in, but I think there's going to be a real appetite for this sort of thing. But the things that that we're working on specifically in our work, and there's all sorts of great bird pictures when you work with Carl. So we have ravens, we have crows, and in this, for us, we'd work on everything that you're working on. For many years, we've been teaching these issues with a class that we teach that we call Calling BS, and then we also I spend a lot of time building curriculum at the University of Washington in data science, and I teach classes in machine learning and statistics. And there's an infinite number of things to look at, but we chose to pick an issue that I've seen, and Carl has seen, and others, and all of you have seen, how challenging just things like outcome switching are in teaching students, not just as the next producers of knowledge, but as the consumers of that knowledge. It's really, really difficult, even if you know about the concept of outcome switching, to be able to figure out whether something has been outcome switched in the literature. There are things that we can teach them. We can talk about running directly to the methods section. We can talk about the ways in which you can use registered reports. And that's actually the big research we have in this space and looking at outcome switching when you do this from a meta science perspective is looking at registered reports. But that's a tiny, tiny section of the literature. And yet even in that, you know, some are reporting, even though the samples are very, very small, 1 in 3 of the one in three of those registered reports examined in some of these studies have been outcome switched. And it doesn't necessarily mean that anything was, you know, poorly done or that pink fingers should be pointed and PhDs should be stripped from names, but this is something that is fairly common, and it means that it's not just happening by inexperienced scientists, it's happening by the most experienced. So we're concerned about this, like many of the issues that we're talking about. So how do we teach this? One thing is to give a student the definition of outcome switching and then say, that's what it is, watch out for it, and don't produce it as a writer and an author. As we all know, we need much more, nuanced, sophisticated ways of embedding this in the brains of our future leaders in science. So we really wanted to do this through experience. Experience is challenging. If you do it in a theatrical way, sometimes it can go wonderfully like a Broadway show, and sometimes it can really land like a dud. But we were committed to really trying to do this through experience. So we have created a pilot. We've run this through a user group of PhD students in the biology department. And for the most part, it's gone pretty well. And I won't go through all the details of that particular pilot, but I'm happy to show that. We have slides of how the pilot we actually ran through that, and we'll be delivering that. But I really wanted just to emphasize that this is our philosophy. This is our pedagogical philosophy. I know there's terms for this in the pedagogy research around this, but experience is really what we're going after. We're essentially trying to recreate a graphic novel that we embed the researchers in, do a little bit of a bait and shift. We don't do bait. And I tend not to use the term bait and switch because we're not switching it on. We're just shifting them in their perspective. So we do a bait and shift. And the way that we do that is we give them a data set similar to some of the interactive things we've seen over the last couple of days, which I think is a wonderful way of engaging a lab meeting and lab and researchers trying to learn about this, and even researchers that have been around for a very long time. And the idea is to give them a particular data set with a particular question that they're after, and you sort of give them, the set of tools that they might learn in their Statistics 101 course. They go through this suite of tests, and from those tests, they come out with some sort of conclusions. But as they're sort of playing with that same kind of data set, they start to realize, wow, look, if we only looked at age from, cutoff of 65 and older, you get this different result. And of course, the eyes light up because we're dealing with humans in science. And we imagine that this could happen for someone experiencing this graphic novel in science. And from that, they would then be put in a situation where they could reflect on some of those things that could have led to this. But the challenge, of course, with this and the things that we've learned through this focus group is that there's a lot of anxiety among the PhD students, both in recognizing that, wow, this really is a problem, but wanting to have just a cookie cutter answer to what you do about it. And as we all know, it's not so clear because if you do switch, let's just pretend this new drug that we have that's treating these particular patients does really work only in a particular age group, in an age group of over 65. What do you do about that? What do you do about the importance of exploratory research? So we're doing a mini unit. Bing, one of our other colleagues, is leading a mini unit on the value and how you might go about sort of carefully controlling the exploratory tendencies, and also and also talk about the benefits, of course, of exploratory research. So we go through this interaction. We talk about what you need to be paying attention, both as the researcher and the consumer of research out in the world. And so that's sort of one of the big units that we're sort of doing. And those are some of the sort of reflections. And Carl, if you had any other reflections you can jump. But the main thing I wanted to talk about is this new thing that we've been having discussions with many of you. And so I wanted to spend the most of my 5 minutes, even though I'm probably getting close to that 5 minutes already, maybe give me like 1 minute, was to at least pose it, because we've talked to Shai and Devin and Conrad and others, and Mariah and others in the room, is that in addition to publication bias, which we have agreed we are very much going to still do because I care very much about this. I am, you can hear me if it's being recorded. I've got it recorded right now that I'm saying this. I'm going to do it. But we absolutely very much want to take advantage of our positioning in this center effort to potentially, help the new scientists, the old scientists trying to grapple with generative AI in science. So my student and I, we recently gave a presentation at the National Academy of Sciences a few months ago where we did a pretty comprehensive, not fully comprehensive, pretty comprehensive survey of the ways in which generative AI is being used in peer review, visualization creation, in writing papers, into doing analysis, into data cleaning, into data annotation, et cetera, et cetera, et cetera. If you're interested in these papers, I have hundreds and hundreds of these papers all classified into these different categories. And one of the big things that I've learned in all of that is that there's no way like that if I'm tracking this every single day, how are our researchers how are they keeping up with this? How could they improve the rigor with this, or make sure they don't make the rigor worse by employing some of these things? So the one sort of statement and question I have for all of you is, how could we link in a lot of the stuff that you're already doing into these discussions about how AI is being used? Because it's absolutely being used. The genie's out of the bottle. And I think it would be a big service to try to create a unit on some of these kinds of things. And we've been doing a bunch of research because that's what we do in my lab, is research around these kinds of things, and to talk about what this technology is, how it could be used in science, and how it could also be damaging of science. And then the last thing is we still also have our questioning statistics, which is actually what rooted from all of the stuff that Carl and I've done. We've been teaching for years about this in a more generalized class that's meant for students in the public writ large. And this particular, some of the sort of principles that exist in these kinds of in these lectures will exist no matter what happens with AI. And so we're looking forward to doing that sort of as our final thing. So with that, I'll give the mic to the next person. Thanks.
Okay, our last team is going to be UT Dallas, and give me a second to escape this. Well, I don't know where. Well, I want to. Great. And then if you want to switch to your present, I don't know. Honestly, I don't know how you go back to it, so we'll figure it out.
It's on Chrome, right?
Yeah.
Yeah, that's how.
Okay, great. Thank God.
So if you do Command between or
You ready? All right. We're the caboose, right? Yes. Awesome. Hello, everyone. We're UT Dallas. My name is Selena Brody, and I am joined by Regina Ibarra and Ben Culver. And last year, we were really inspired by Conrad talking about storytelling and narrative and wonder. And so we promised to tell you what we've been up to, but we're going to start with a little story. Okay. Oh, wrong. No, I'm not. Sorry, I did it wrong. You shouldn't have let me in charge of that. Let's see.
There it is. Ooh,
Too far.
Okay, there you go.
no, it's still not showing the image. There it is.
Yeah.
Here we go. Okay. So we're going to start with a little story. Okay. History has not been kind to Tom Bordelon and Charles Evans. Nobody remembers these two men. They actually accomplished an incredible feat. They crested the south summit of Mount Everest in 1953. That's 8,748 meters of elevation. They were just 101 meters short of the summit.
But they had to turn back and return to camp because they lacked the proper tools and they did not have enough oxygen to continue on. So sadly for them, they were not the first to reach the summit of Mount Everest, the highest point in the world. That honor goes to, you might know this fun fact, Edmund Hillary and Tenzing Norgay. They did have the proper tools and the training to reach the summit 3 days later. They become two of the world's most famous men. Hillary becomes knighted, Tenzing receives British and Nepalese honors, Bordelon and Evans are living with regret. So mountaineering, we're thinking, is a pretty wonderful metaphor for doing rigorous research. Our unit is going to take you on a journey where we're going to explore the challenges and the risks with planning rigorous research studies. And we're specifically going to focus on defining and distinguishing between hypothesis generating and hypothesis testing research. So we're not here to tell people not to celebrate where they're at. So where Bordelon and Evans were at the South Summit is really impressive. That's something to celebrate that they got to that point. But it would be wrong to claim that they actually were at the summit when they were not. And that makes a lot of sense to us. So we're going to be showing you, using this mountaineering imagery, some ways that we can think about and help our learners imagine this difference between hypothesis generating and hypothesis testing using kind of this mountain approach. So I'm going to pass it over to Ben to continue.
Great. So, one of the things we, knew at the beginning, but it continued to expand as we explored this space, is how it's not black and white between exploratory research and confirmatory research. We started to sort of expand the space in between this and using this same sort of mountaineering metaphor to really help learners point out the fact that most people, when they're doing confirmatory research, are in this sort of pre-confirmatory state, right? So it's a false summit. You think you've tested the hypothesis, you think you're done, maybe you've done a couple small and blinded pilot studies, but you haven't gone all the way to the end. You haven't summited and you haven't gotten down the other side, right? Most people die coming down Everest, not going up. And so there's a lot that actually can be unpackaged from this metaphor to sort of help people. But the ultimate goal of our unit is to help people identify where they are in this exploratory confirmatory space, and or if they're reading papers, where that paper actually is. And so to sort of take them to that point, we developed this theorize, realize tool, which we just want to briefly share with you. Well, maybe not. Yeah. Yeah, go ahead. It's okay.
There, no, what's my fault?
Oh, it's down there. I could have done that. Yeah. Thanks.
Yeah, is that already? You can do.
Well, we'll see. I was hoping you would do it. Look like I know what I'm doing. You just get back to Chrome. Get back to Chrome.
Okay.
Here, let me get.
This is not open.
It looks like it's not open. Yeah.
Let's just.
Yeah. Good.
You know what? I was about to quit, but I'm afraid to.
Is it in downloads? Maybe.
It's in download.
Yeah, if it's in downloads, it's probably in the bottom right corner. Yes. This is it, right?
Nope. Edit?
There it is.
Nope.
There it is. There it is.
Thank you. Okay, appreciate it. Okay. Okay, so this is a tool. It's called the Theorize Realize tool. I'm just going to walk you through this first page, but it's a tool designed to help research determine where they are, okay, on this continuum of exploratory hypothesis generating and confirmatory hypothesis testing research. And so the idea behind the tool is to help people realize, to understand where they are in this space. So the first sort of step is, are you pursuing your own work or are you reviewing someone else's? Okay, and so basically they can go through and they can click these various buttons and it says, great, you're developing, you're doing your own work. Have you developed your own hypothesis? Yes, I have. Let me go to the confirmatory process. And anyway, the point is it sort of walks through this whole process. And then at the end, you get a summary and you say, here's the things that you've walked through. And so, yeah, this is where you are on this mountain. This is where you are between sort of exploration and confirmation. And so let's see if we can get back to PowerPoint.
So what about the difficulty that there's a lot of variety across studies? Is the tool really gonna universally work?
I mean,
Of course. This is a silly question, Conrad. So, I mean, I want to illustrate the point that we can't build everything for everyone. And I think for us, it's like sort of MVP with the sort of world of neuroscience that we work in. But yeah, fair points. I mean, I think there's going to be elements that won't work. I will say that one of the things we're working on is fewer sort of yes/no divisions in the tool, so that it is a little bit more flexible. But of course, feedback in that is going to be really important if we actually use something like this. Yeah, and that's what the back end looks like. So, but if you are thinking about a decision tree, this is a fabulous tool. It's called Twine. I can teach it in 5 minutes, and it's really, really easy to use. So if you're trying to build a decision tree that doesn't fit on an 8.5 by 11 piece of paper with five decision points, it's a really, really fabulous tool. So, okay.
so we're not necessarily saying that this is an easy or a simple tree, but just with yes, no answers, this is the level of complexity that we can get and walk people through in a relatively easy way. So just to kind of tell you a little bit more about where we've been and what we've been doing, actually, most of the steps of especially this unit, we've either used students to help us think through some ideas and then also pilot tested some of the ideas with both undergrads and graduate students. So Selena, Ben, and I actually ran an undergraduate student group last year where undergrads from all different areas of the university got to work with us, and they were able to help us to narrow down some ideas and to brainstorm some ideas and also some activities. I mean, some of these students created whole complex board games you can play to identify your level of research complexity and confirmation level and all of that. So we did that. Also, once we kind of came down with the mountain, Ben piloted it with some of the different students where students actually got to play in person some of the activities that we're actually proposing to have included in the unit. So activities where they're given a limited amount of resources, limited amount of data, and they have to decide where and how to spend those resources. And then we tell them things like, actually, the studies are at different places on this mountain. Now, what do you do? And as you can see, like these are action shots. There was a lot of engagement and students were able to, in a different way, see why these different levels of research matter and the kinds of questions that different levels of research can answer. And then it's not, exploratory research or research somewhere in between, or even going up the peak for the confirmatory research is all important. It's just that the level of conclusions or the kinds of questions we can answer is going to vary, and how much resources you want to devote to the different kinds of levels of research is probably going to vary too. So we're able to kind of work with students to gather that information. Just to tell you a little bit about overall what we're doing. So this was the first unit that I was talking about, basically looking at this idea that, and driving home the point that most people often may be thinking that they're doing confirmatory research, but they're probably not on that way down that mountain. They're somewhere before that, and allowing them to position themselves a little bit to be a little more accurate and kind of know where they are. Our other units are looking at lab notebooks and making sure that we are recording and writing down information correctly so that we can be accurate, transparent, and kind of how we're able to pass on that information. And then our last unit is all about reporting study findings in a transparent and accurate way. And so these units are in various stages of development. With this exploratory confirmatory unit, we just submitted our long form. So we've put together a bunch of mini units. Unit 2 is on its way, and Unit 3 is the least developed, but also moving forward. And that's all we have.
Thank you.
Okay, thank you to all of the meters for your presentations over the last 2 days. They've been really, really wonderful. I really appreciate that you all responded to my little requests for reflection. We're going to take a 10-minute break, and then we're going to jump into our little game. So come back around 5, I'm sorry, I used military time, 3:30.